Welcome to today's webinar titled Parking Garages, Playing Your Cards Right. My name is Billy Zadig, Manager Special Programs for APA. A couple of housekeeping items before we get started. The webinar recording will be posted to APA website later this afternoon. Please visit our website at www.apa.org to register for upcoming events and to view archived webinars for continuing education credits found under the Continuous Learning tab. APA-U is back, live in person, and coming to Providence, Rhode Island in September and Fort Worth, Texas in January 2023. Information is available on the APA website under the DLS tab. Professional continuing education certificates being offered for today's program. AIA members who need their attendance reported to AIA should contact me at Billy, B-I-L-E, at APA.org. Those who indicated they wanted a certificate at registration and meet the requirements will receive certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question prior presentation. If you're just calling in, make sure to send me an email at billy@apa.org. I can send you a certificate if you would like one. The system recognizes if you log in. Before we get started, I wanted to give you some information about our speaker today. Allison O'Neill is a professional engineer and an associate and senior structural engineer at GALE Associates, Inc. GALE is a consulting engineering firm specializing in building enclosure design, consulting, structural engineering, athletic facilities planning and design, building enclosure commissioning, civil engineering, and aviation engineering. Allison is the head of GALE Structures and has extensive experience performing evaluation, engineering analysis, design and construction phase services for commercial, industrial, and institutional projects, construction, steel, timber, masonry, concrete, and other materials. At this time, it's my pleasure to turn to Allison O'Neill. Allison, take it away.
Thank you, Billy, and thank you all for joining us today. Good afternoon. We're going to talk about parking garages today. So we have a few introductory slides here about your AIA credits, but I think Billy just covered all of this information. A little bit about today, we're going to talk about parking garages and how they are a very important asset to colleges and universities. And just knowing how to understand your parking garages better from a structural system standpoint to basically understand your hand and what cards you hold in your hand, and then talk about what the opponents might be, what the mechanisms of deterioration might be for your parking structure. And then we'll go into kind of the game of what your repair approach might look like and what you should focus on, and also talk about some strategizing after your repairs are done, or even maybe before you have to perform repairs, talk about the strategy behind how you would approach maintaining your asset, your parking garage. So I just went over those learning objectives that we're going to cover today. And so these are our 4 sections. We kind of used 4 playing cards to identify each section of the presentation. So the first section will be to talk about the structural systems, advantages and disadvantages of those systems. And then the second section would be the deterioration section. The third would be the repairs, and the fourth section will be talking about maintenance. So what cards do you hold in your hand? There are 4 major structural systems that I'd like to talk about today. There are additional different types of parking structural systems, but most of the garages fall into these 4 categories. So the first one we'll talk about is a total precast concrete system. And when I say total precast concrete, I mean the superstructure, because you're looking at a cast in place foundation for pretty much all of your structures. The second type would be a cast in place concrete system. which would be just all cast in place and nothing cast off site and brought to the site. The third type would be structural steel and precast concrete, which is a hybrid system. And the fourth type of structural system is a structural steel frame with metal decking and concrete poured on top of the metal decking. Oh, sorry, this is lagging a little bit. So for the total precast concrete system, you have a cast in place concrete foundation that takes some time to excavate and pour. And then when you look at the superstructure, it is actually all fabricated off-site and shipped to the site in pieces. And the photo on the left, you can see the crane is in place and it's actually erecting one piece of precast. And when that piece is placed, there are some welds that happen or some bolting in place, and then they move on to the next piece. So, and then the photo on the right shows a facade of a precast concrete garage, and you can kind of see the jointing of how that all kind of comes together like a set of Legos. The thing about pre-stressed precast concrete is that most of the long span members are pre-stressed. So if you're looking at the photo on the left, the members that span from left to right are 60 feet long. And how they make those is they actually, they put the pre-stressing strands in these forms, and they have the end pieces of these forms are fixed, and they actually pull them at each end and tension the strand before they pour all the concrete in the form. And they allow the concrete to come up to about 75% of the total strength of the concrete, which they can achieve in about 1 day in the plant. And then they release the strands, and the strands put a tensioning force at the ends, which helps with the flexural strength of those members. So I'm going to talk about some pros and cons about this construction method. The pros can be because they are prefabricated elements, they have a certain level of quality control that they can maintain. Typically the precast concrete plants, a lot of them have these very high roof structure, headroom structures with overhead cranes, so they can pour these without having rain on them or any kind of weather effects on the fabrication process. The other aspect of the precast concrete is there's an institute called the Precast Concrete Institute, and they certify these plants, and this organization does inspections on these plants to make sure that they're keeping proper records, that their concrete is coming up to strength the way that they have been stating that it comes up to strength, and that they're doing all of the quality control procedures that they need to do. So as a result, you end up with a superstructure that is more durable than, say, a cast in place concrete structure with some respects. We inherently, with a concrete structure, have cover on the embedded reinforcement, so that provides some protection for the structural part of the concrete. And as you could see from the photo that I showed you earlier, the construction schedule can be expedited for the superstructure because the crane will put up 20 pieces a day, sometimes even more, and it goes really quickly when you're in construction. Another advantage can be that some of the concrete has inherent fire resistance, so you don't need to apply, say, a fire resistance coating to the concrete after it's poured. Some disadvantages to this system is that because they are individual pieces and they come to the site, they need to be connected, and they're typically connected by welding the connections together. So you need to protect the metal connections, right? So you have steel, they're mostly stainless steel, but you still need to make sure that those connections maintain some level of protection so that they don't deteriorate over time. So that can be a disadvantage. And if the pre-stressing strands end up being damaged by long-term deterioration, those can be costly to repair and can sometimes involve shoring the garage and making sure that you do the repair correctly, and that can be expensive. And then the only other thing with precast is that the lead time for initial construction can vary based on the market and what the demand is. The next structural system I wanted to talk about was the cast-in-place concrete system. So just like the foundations are formed and poured in place, a cast-in-place concrete system is formed and poured in place and often requires some level of shoring, temporary shoring, while the concrete comes up to strength and then those forms are removed. The quality control in the field can vary depending on how much construction oversight there is during the construction of the garage. And I'll just flip to this next slide where I have the pros and cons on here. So there are an advantage to this system is that there are fewer joints. So unlike the precast concrete system that I just discussed, the cast-in-place concrete system has continuous joints. Oftentimes the reinforcement is run continuously through like a beam to column connection or a slab. Everything is sort of tied together continuously, so that can result in less deterioration of the joints depending on the level of maintenance. But just something to be aware of if you have a cast-in-place concrete system, that's how it works. And if you have a precast concrete system, you have a lot of joints that you might need to maintain or repair over time. The cast-in-place concrete systems are oftentimes used if they need flexibility in the framing. If you have an odd footprint for the structure when laying it out initially, and you need some options for ramping or just different types of bays, chamfered sides of the garage. Those are also advantages to considering cast-in-place concrete system. And the long span condition that I was talking to you about with the pre-stressing, that can be achieved with a cast-in-place concrete system by using post-tensioning. So it's a very similar concept to pre-stressing, but the tensioning actually happens after the garage is poured. So what happens with the post-tension system is the strands are actually draped inside of the forms and the concrete is poured. And then after the concrete comes up to adequate strength, the tensioning cables are pulled tight after the concrete comes up to strength. So that's why they say post-tensioning for a post-tension cast-in-place garage and pre-stressing for the precast garage, where you have the stressing happening before the concrete's poured. Some of the disadvantages for cast-in-place concrete system, as you're looking at kind of your hand of cards per se, your quality control, as I had mentioned before, all of your reinforcement is being placed and your forms are being done in the field, and depending on your level of oversight during construction, the concrete trucks also need to be, they have the ready-made, the concrete comes from a concrete plant. So that needs to come in a truck that is continuously rotating the barrel of the truck to keep the concrete at the right consistency to be poured. But the time in the truck and sometimes water is added to the concrete on site without that being in the specification. So all of these sorts of things have an effect on the ultimate quality of the concrete as it's installed. If the post-tensioning strands that I just discussed were to deteriorate, those repairs can be very costly. To try to get, basically you have to identify where your post-tensioning strand is broken and then try to come up with a repair to restore the structural capacity of that post-tensioning member. Cast-in-place concrete systems that do not have post-tensioning are oftentimes very short spans because cast-in-place concrete that's conventionally reinforced just doesn't have a long span capability. So what you end up in that case is with columns right in the middle of where you could have a parking space, and it can affect how many parking spaces you're able to actually get into your parking structure. And the construction schedule can be a factor in the decision on whether to specify a cast-in-place concrete system, because the construction schedule is a little slower for the superstructure when it involves the forming, the shoring, and waiting for the concrete to come up to strength and then getting to the next level. So we'll move on to the structural steel with the precast concrete deck. The structural steel frame is going to be just constantly exposed to the weather. So you are just going to make sure that, you know, with time that you keep that steel protected with this type of a system. So I'm going to, in this slide, you can see the blue is the structural steel and the gray is the concrete spandrel, and the interior decks are precast concrete. So you can still get a pretty long span with the precast in this situation. So the advantages can be that you have a precast concrete deck that has a quality control in the plant. You have the concrete cover again with the concrete members, and you can see the deterioration of the steel. So if you are doing regular evaluations, you can actually see that when something's wrong ahead of time. Whereas with the concrete, sometimes it remains fairly hidden if you're just kind of doing a visual evaluation over time. Steel, the steel connections can be something that is susceptible to deterioration over time. Again, pre-stressing repairs can be costly if it gets to that point. The durability of the steel frame can be a concern if the maintenance is not kept up with. And the no concrete cover on the steel can be susceptible to more deterioration if the paint that is, the paint coating is deteriorating over time. And sometimes with the steel frame garages, there is a fireproofing requirement. The last structural system I wanted to talk about is the structural steel with a metal deck and concrete slab. So the way this system works is there's a structural steel frame that's erected, and the metal deck is supported right on top of the steel beams, and then a concrete slab is poured on top of the metal deck. A lot of times these systems are a little more susceptible to deterioration, but can be still maintained and have long service lives. So you just need to be aware of, again, cards in your hand and what you need to do to basically extend the service life of your structure. These structures tend to be lower initial cost, and they can be quick to erect and install. There's more flexibility with the framing options with this one, because structural steel, you can do virtually anything you want to with it. Deterioration is exposed and observable if you're looking for it. The disadvantages can be the quality control, as we've talked before about that. The durability of the metal deck is very susceptible to deterioration. We'll talk about that next, how the moisture will get into the concrete, and then it really doesn't have much of a place to go when it hits the metal deck. So it oftentimes will sit on the metal deck and cause more deterioration that way. And there's really no concrete cover on the steel, and some of it may need to be fireproofed. So that was a long first section, but to understand really what you have on your hands is really important when you think about, how do I take care of this asset and what do I need to do to repair it, and to just really understand what's happening. So the opponents are the deterioration culprits. There's four of these that I'd like to just briefly go over: harsh weather exposure, de-icer chemicals, failed drainage systems, and failed waterproofing systems. So before I dive into that, I just go over a brief description of the majority of the concrete defects that we see have to do with the ingress of water, and depending on your geographical location, if you're using de-icing salts, chlorides penetrating the concrete, because concrete is a porous material. So even though it looks solid, it does have air in it and does have pores that the water can get in to the concrete and eventually reaches the reinforcing steel. So when it reaches the reinforcing steel, there is a protective coating on the steel inherently, but eventually that erodes and the concrete starts to rust. And as the rust builds up, it exfoliates and causes an expansion of the reinforcing steel area. And the concrete material itself is very, very strong in compression, but it's very, very weak in tension. So that's why concrete cracks. And when the expansion forces from the exfoliation of the steel happen, you can see in this diagram where the tension forces are just forcing this concrete to pop off and fall. So when you see exposed reinforcing steel or you see pieces of concrete missing, this is most of the time what's happening below the surface. So with harsh weather exposure, we see that's a lot in climates where we have quite a bit of snow, and clients don't always have the ability to dump the snow off the side or have a snow gate to push the snow off, or even a snow melter situation where you'd be able to melt the snow on site. So sometimes, and this is in a city setting, these photos are of a parking garage where the owner needed to be able to clear the snow so that people could park, but didn't really have anywhere to put it. So they put the snow in the corner, and at the end of the winter it's gone, and they kind of move on. But in this pile of snow is also de-icing salts and whatever they have used to treat the decks ahead of time, or even during the last snowstorm, they clear the snow and then they salt it or whatever they do, and then it all piles up, and then eventually it melts. So when that snow melts with the chemicals inside of it, the chemicals get into the concrete through cracks, through the pores, before it gets to the drainage. Some of it gets to the drainage system, and the part that doesn't sometimes gets into the decks. So then that kind of leads us right into talking about de-icer chemicals. So it's a catch-22, because as a university or a school, you need to keep your pedestrians safe, and you need to be making sure that the cars are not going to be crashing into the sides of the parking garage. But on the same token, the garages are made of concrete, and the salt isn't great for the concrete. So it's kind of a caught in the middle of two things that are pulling you in two different ways, right? So how do we deal with that? Well, we'll talk about what the de-icing chemicals do to the concrete, and we can talk about ways that we can still use some chemicals to melt the snow, but maybe ways that we can kind of counteract that in another way. We'll talk about that a little bit later. But these are just photos of the de-icing salts that you can see, and some water that's kind of suspended on the deck that hasn't quite made it to the drain yet. And we talked about how the chlorides, once they get to the steel, along with the moisture, they actually accelerate the deterioration. So if you just have water getting into your concrete, it can still cause the deterioration of the steel and the exfoliation and the spalling, but the chlorides tend to accelerate that chemical reaction. So these are just another slide looking at the underside of the concrete decks. So on the left, you see a concrete on metal deck slab with structural steel framing supporting the slab. And this is actually an extreme case where this has been ongoing for a long time, where the moisture and the de-icing salts have gotten so bad into the metal deck. The metal deck's starting to deteriorate, and allowing that to get into the structural steel. This was once covered in fireproofing, and the fireproofing has even come off of the steel in this situation on the left. On the right, this is a precast concrete garage that didn't have maintenance on the joint sealants. So the joint sealants that I was talking about earlier, those are the ones that protect the connections between the precast concrete members, but they also protect the structural load carrying members below. So on the right, you can see the precast concrete has deteriorated. There's a pre-stressing strand along the bottom of this picture, and there are stirrups from the beam that are also rusted and need to be repaired. And that's just because the joint sealants above had failed, and the water with the chlorides was getting through the joints and down into the concrete and then into the load carrying members. All right, the next one is a failed drainage system. Failed drainage systems can fail in different ways. They can crack and cause leaks, or they can just be clogged and need to be cleared. So I included this photo on the left because this is a cast in place concrete pier with a precast concrete column above it. And what happened in this situation was the drainage wasn't working above, and so the water was backing up and it was finding its way through the joint sealants and down the side of the column, and then it reached this foundation where the quality control was a little bit different. There was a ledge to catch the water, and it just over time ended up really deteriorating. So the photo in the middle shows after we demolished the concrete that was not sound anymore, and that's what was left. So in this case, because this had gone on for so long, the whole garage needed to be shored up. So we have, on the left, you can see some post shores, but there were shores for the main load carrying girders. On the right, actually the right photo, you can see one of the shores that's holding up the girder. That's another location in the same garage. And all the way up to the roof, we had to shore this so that the repair to the foundation could happen without a risk of anything happening while we're making that repair. So the failed drainage systems can be a real problem, especially when they're clogged and then the water needs to find a new place to go. These are just other photos from the top side. On the left, we have just water that can't get to the drain. In the middle, we have just a clogged drain, the water building up, and when it sits on these joints, it will find its way through and then eat at whatever's there. On the right, we have another photo similar to the first one, but a different garage, where the water just was coming right down the side of the column. And when it hit the cast in place concrete foundation, that's where it really did a number. So when we sounded this out, we were hammering, it's a way to identify unsound concrete. We're hammering around the side of this. The entire concrete cover of 2 inches was completely gone and ready to come off. So for the repair for this structure, we also have to shore this up to the roof to make these repairs to be sure that the whole foundation pier doesn't fail during the repair. This is another photo of the basement where there's even more ponding on the left, and then another photo on the right where there's just a drain body that is disconnected. So the last one is failed waterproofing systems. So the failed waterproofing systems, what we're looking at on the left is a traffic coating. You can see the difference in the color of the concrete. The grayer on the left, that's where the traffic coating is, and it's just a membrane that covers the concrete decks to try to protect the deck as best as we can from the ingress of moisture to the structure. And then below the traffic bearing membrane in this case, there are joint sealants. So those joint sealants in this photograph have also failed. So you can see the line along the left side of this dotted line where the joint sealant has come apart from the concrete, and then also the traffic coating has failed there. On the right is an example of what you'd see when this fails, and we had several of these on this garage where the concrete just ended up blowing through the flange. This is a 4-inch double T flange. So this is just an example of a waterproofing system that you can actually see in the right photo that there are drops of water that are coming through. It's just actively leaking. When the waterproofing system does fail, then this is the kind of deterioration that you end up seeing. This is a close-up on the left. This is a close-up of a joint sealant on a precast concrete system. This is a joint between 2 double T beams, very close up, showing you where the joint sealant has failed and allowing moisture to get into the joints. On the right side, this is just looking underneath an example of what you'd see if your joint sealants had failed and started to deteriorate your steel connections. So you've got 2 metal connections welded together, and when that moisture gets in, it can corrode those and cause this type of staining. And one more slide with the failed waterproofing system. We have a situation on the left where we have a traffic coating that is deteriorated. There's a metal plate on the floor where we actually had a blow through on the 4-inch flange, so we had to put a roadway plate there until the repair could be installed. And on the right, that's another example of where the waterproofing has leaked and there's been a blow through, and there's actually a roadway plate on top of that double T-beam to sort of help with that until they can get the repair put in place. On the left, we have a failed expansion joint, just has completely surpassed its useful service life and needs to be replaced, which is allowing, again, moisture to get through. And same thing with the failed joint sealant on the right. That joint is completely gone and needs to be replaced. So let's go into the third section to talk about the game. So now you know what cards you have, what cards your opponents might have, and now you need to figure out, well, how do I approach this game of repair? Because I know my garage needs repair. I can see this, I can see that. What's going on? So the step-by-step process that we typically take is to address the immediate safety concerns. These are typically areas of concrete that have spalled, but haven't completely broken apart from the structure and might actually fall from overhead. So those would be immediate safety concerns. And then the next thing is the structural deterioration that needs to be addressed. It's not a safety concern yet, but will be in the future. Then we go to minor defects. The thing with the minor defects is you do want to repair them because they eventually end up migrating into the structural deterioration category. So if you can repair the minor defects ahead of time, then they are a little less costly than the structural deterioration ones. And then cosmetic repairs would be the last one. Now, I know that most people would like to see the cosmetic repairs happen first because you want a garage that looks nice and feels good to be in. But from a repair standpoint, we want to try to take care of the other items first. So the immediate safety concerns are definitely something that you want to take care of right away once you know about them. This is actually an example from a garage that we worked on recently where the owner said, this doesn't really look right, can you come out and take a look? And so we did, and we noticed that there was quite a bit of deterioration that you couldn't see, but there was certainly quite a bit that you could. And we didn't even dare start tapping this because it looked like a really heavy piece of concrete was going to be falling. So when you look at this picture, it might look like a lot of cracking. But in fact, what's happening is, if you remember this image that I had showed you before with the structural deterioration, what's happened is the reinforcing that's inside of this beam has started to corrode and exfoliate. And what it's done is it's expanded enough that it's pushing the concrete away from the rest of the concrete. So all of this, and it even comes back to the column here, but all of this along the bottom, if you can see my cursor, that is all just not bonded to the rest of the concrete anymore. So that has the potential to fall. So what we ended up doing is we worked with the owner and had a contractor cut out and just we marked all of the areas that were called hazards and just remove these first is the first step. Before we design repairs and everything, just remove this. And this piece of concrete on the vertical face is also one that, that we had them removed, all this stuff that's just kind of looks like it's going to come out. And this is just another slide showing some examples of safety concerns. Again, it might look like cracks, but what we're seeing here, and you can sound it with the hammer, we can do different kinds of sounding techniques to identify what is still bonded to the concrete and what's not. But that's a safety concern where you want to have that removed so that you don't have it unexpectedly fall on a person, a car, just in general. When concrete falls, people don't feel as safe. And on the right, same thing. You can see some of the reinforcement there. You can see some cracking, but really that's all hollow underneath there and needs to come down. This is another example of looks like cracking on the left, all hollow. When they came and knocked the concrete out, that's what it looked like on the right. So the next approach would be to talk about structural deterioration. So these are the items that are going to end up in could need to be shored in order to repair them. Or if we don't repair them now, we're going to be looking at shoring the garage at some point in the future. This slide is just seeing, you can see this is the same beam, but this photos are taken from two different angles. So the photo on the left is a photo of this beam from the underside looking up. This is a precast concrete garage. This is the one that was actually not maintained very well over time. And there was a previous repair to the concrete that has failed since. So you can see the cracking, you can see the different colors of concrete where the old patch was and where the original concrete is on the right side of the photo. And then on the on the right photo, if you look, this is taken from the other side of the garage, and you can see the fire protection pipe in both photos. This is the fire protection pipe on the left, and then it's on the right side in this photo. And this is after we have shored the garage. So we shored this level, and what we did was we supported the double T-beams on both sides of this IT girder so that the IT girder was only holding itself weight when we did the repairs. But this is within months of each other, and you can see on the left where it looks like something's going on there. We're not really sure until we open it up how deep these repairs are. And on the right, you can see this is how much deterioration there was. What you see as smooth concrete there was the only sound concrete left. We took out the concrete that was unsound after this photo was taken, coated the rebar with a corrosion resistant paint, and performed a repair that hopefully was designed to last a lot longer than the one that was there before. So the next category of repairs would be the minor defects. So these photos show some minor defects. The one on the left shows some spalling. You can see some rebar exposed. If this one's not repaired right now, not the biggest deal, but if you don't repair it in the next year or so, you're going to see this just continue to spall. The other concern with this one on the left is the tripping hazard. So you want to try to take care of your tripping hazards. That could actually end up falling into the safety hazard category. And so you want to take care of these minor defects before they end up being major defects. On the right, you see there was a crack that was repaired with that gray, the gray color. That's a routed crack, and it's sealed with sealant. And then there's some spalling and some cracking that needs to be repaired there. Again, just avenues for the chlorides and the moisture to continue accessing the concrete pores, which eventually get down to the reinforcement and cause the corrosion. This is another minor defect. We have on the left, we have a traffic coating around a trench drain, and the traffic coating has worn out on two areas, almost where the wheels would be driving over this. And you can see there's a crack. If you can see the photo well enough, this crack's running through this area where the traffic coating has come off. And with the traffic coating can bridge cracks up to a certain width. So if you reinstall the traffic coating, you either route and seal the crack first, depending on the width of the crack, and then put the traffic coating on, or the traffic coating, depending on which product you use, you can just coat right over all these cracks in it. And it forms a continuous membrane so that the water can actually get to the drain before it gets into the concrete. On the right, you can see this is a previously routed and sealed crack that the sealant has come out and needs to be re-prepped and resealed. And there's another crack to the right of this crack that also looks like it could be routed and sealed to try to preserve that concrete surface a little better. And then the last item on the list of importance would be the cosmetic repairs. This is a concrete masonry unit wall to a stair tower, and there's been some moisture exposure, there's some peeling paint, and so we want to get to the bottom of why that moisture exposure is happening and do any masonry repairs that might be required, but then, you know, repaint the stair tower and make that look a lot more welcoming. So this fourth section is the strategy. So we've talked about the cards that we have in our hands. We've talked about the deterioration mechanisms. We've talked about the game of how to approach the repairs. And so now we'll talk about the strategy behind how to maintain the garage. So with maintenance, you want to think about, for structural maintenance, you want to think about all of the elements that we need to worry about on our garage. We have the floor slabs, which are going to see all the vehicular traffic, and especially our roof decks, where we have all the rain and potentially snow exposure to the moisture and whatnot. We want to take care of those roof slabs. So you're going to be looking at cracks, spalls, joint sealants, maybe some traffic coatings that you've added to your garage, or maybe they were there from the initial construction that you want to really make sure you maintain. Another item about the traffic coatings is that once they have a breach in the traffic coating and they start to debond from the top of the concrete, they actually will hold moisture that gets under there. They'll hold it against it longer than if it were able to just evaporate naturally from the slab. So it can actually exacerbate the issue if the condition of the traffic coating becomes worse. So beams, columns, and walls. So these are the vertical supporting elements of your structure. They hold the floor slabs, and you need to make sure that you're having those evaluated on a regular basis, so that you're aware of any issues that are happening early on. And so we'll talk about what happens if it goes on for too long, but those are very important structural elements. The stair and elevator towers, you can have the deterioration of the stair elements, the walls, so you want to be aware of what's happening there and to fix those, especially since those can be big trip fall areas where you have a pedestrian safety issue. Joint sealants, when you have, even in cast and place structures, but mostly with precast, you have a lot of joint sealants that need to be maintained, and you want to make sure that whatever product was there and whatever service life you expected out of that you kind of looking at those joint sealants, seeing if they've failed, and making sure that those are replaced by a qualified contractor, so that those joints are protected. Any exposed steel, if you have a steel frame garage, you want to look at whether or not you see any rust happening. Then we want to take off the paint, not just paint over it, but take it out down to bare steel, and put an effective waterproofing coating on the steel after you've cleaned it down and gotten it down to the bare steel. Masonry, typically in garages, you see the masonry construction in the utility rooms or the stair towers like we looked at just previously. And those items, if there is a lot of moisture getting into the masonry, those elements can be load bearing and they can require repair. So it's just another item to look at. And then bearing points. So that kind of goes with the beams, but anywhere you have a beam that is bearing on a support, you want to look at what that bearing looks like. If the beam looks like there's something going on, or the corbel that it's supported on has cracks in it, like we saw in the pictures, any signs of deterioration there would be important so that you don't end up with a failure. This curve might look a little scary at first, but it can be simple, so we're going to just talk through it. This is an example. This is all kind of a pictorial way to show what happens with the parking facility deterioration. So you build a new parking structure. It's hopefully in excellent condition when it's turned over to the owner. And the deterioration level starts really, really low. Like, it's not going to deteriorate really quickly in the first few years. So on the left, the condition level is on the vertical axis, and it says excellent, good, fair, and poor. And on the bottom axis is time. So time is 0 on the left, and then time increases as you go to the right. So as the new parking structure goes along with time to the right, the deterioration causes the condition level to go from excellent to good, and to fair, and to poor. So if you weren't to maintain your garage at all, you would just follow that curve all the way down to the condition level is poor and it needs to be demolished. And essentially how you assess that is if your repairs are going to be equal to or within the range of a demolish and rebuild, then you'd probably choose that option, but try not to get that far along. So you can also see there's like a little repair cost column on the left side of this graph, and at the top is low. So as you go along the deterioration curve and your garage gets from excellent to good, if you perform maintenance at point A, we'll follow that along with the blue line. If you perform maintenance, the repair cost is relatively low compared to if you don't maintain your garage as much and you have it deteriorate even further down the curve. So you invest, this is the idea with the maintenance proactively, you invest in maintaining your garage and you bring it back up a little bit on the deterioration curve, and then it sort of follows that same initial curve after you've done a repair early on. If you have a garage where the maintenance hasn't been effective or hasn't been frequent, then this is called the delayed and reactionary maintenance. So you follow the orange line all the way down to point B on this, and then you realize you're in fair condition and your repair cost is moderate to high. So you've got the B point, and then you do your repair project, and say theoretically it brings you back up to B prime. Well, the amount of cost it's gonna take you to get back into the good category probably won't be worth that investment. So what you're gonna end up doing is you'll invest, and then much quicker you'll have to invest that same amount, and then just to maintain that fair condition, you'll be performing your repair projects more often, just to try to get to the fact that you don't want to have to demolish your garage and rebuild. So just to close out on this, I wanted to show some photos of, delayed and reactionary maintenance section of that curve with the temporary shoring projects that we've had recently. So this project was actually, this was very challenging. We had 5 levels on this garage. But the lowest level so this garage, just to backtrack a little bit, this garage needed to be kept open full time. It was a 24-hour garage. And so on the upper levels, I'll show you a picture in a minute. On the upper levels, we had shoring beams that actually spanned across the drive aisles and had shoring towers on the left and right of the drive aisle so that cars could still pass through while the repairs were being made. And the repairs all needed to be made overnight when the traffic was lower. But this is the basement, and the unique situation in this basement was that we had to close the basement level. And here you can see on this picture there's like a slot in the ground, and those are precast concrete slabs, and there's a steam tunnel running underneath these precast concrete slabs. And so we couldn't bear on these precast concrete slabs because it wouldn't be able to support the weight of the structure above. So we had to use shoring beams, which were the steel beams that you see at the bottom of this photo, and they span across to where the columns are, and then the shoring is supported on above. It's very expensive operation, and this is actually the same location as one of those repair photos I showed you earlier, where you had a beam and all along the beam was deteriorated, and you had the fire protection line right next to the beam. This is that same area. This is another photo of another photo I showed you earlier, which was one of the safety concerns, where we had them knock down the loose concrete, and this is part of the structural repair phase where we had to shore up part of it. Now the disadvantage on this one was that this shoring arrangement, they actually had to take part of the garage out of service, and they're not loading the garage above because there are structural concerns with this beam. Now we're repairing this garage now, and it will be back in service. This area will be back in service shortly, but it just shows you just some of the things that if you are able to invest in that maintenance early on, then you won't end up in a situation where you need to shore and that kind of thing. This is the original shoring photo. I showed you that on the other side of the garage, we're doing another phase, and it just shows you how much shoring is in place, and we're shoring the beams on either side of the inverted T-beam, and then also the inverted T-beams are shored on either side. Just a lot of shoring, supporting the stems so that we can make repairs and then wait for those concrete repairs to achieve their strength, and then release the shore and allow the structure to function as it was before. And this is that same garage. We have the shoring beams at the top of the drive aisle. You can see these metal shoring beams. They're actually 10-inch deep, I think 10 by 39 beams that span over to the shoring towers. And at every level, the shoring tower is picked up again on the level below. So we have a continuous load path all the way down to the basement. But this allowed the owner to keep this parking garage open to the tenants. They continued their revenue stream and were able to just accommodate all of their parking patrons for a longer time. So this is the end of the presentation, and I just wanted to thank you all for joining me today. And this is the AIA credit number, which I think you're going to get from Billy anyways in an email. And I was going to take questions and provide you with my contact information if you have any other questions or want to contact me after the presentation. I'm happy to talk with you.
Thank you, Allison. We do have questions coming in.
Oh,
our first question is, how effective are coating systems at protecting the reinforcing steel in CIP parking decks? And how often does a coating need to be reapplied?
That's a good question. So CIP would be cast in place concrete for everyone, and a cast in place concrete parking deck, depending on what kind of cast in place concrete you have there. With the post tensioning, you might not need a traffic coating system because the post tensioning actually puts a tensioning force on the end of the slab and closes a lot of the potential cracks that might happen. But then again, it's not always a bad idea to do it. So if the traffic coating system is applied properly and the substrate is prepared properly with the cracks and all that, they are very effective with waterproofing the decks. Now, as far as how often they need to be replaced, as with anything, is how much is it used and how, what's the wear and tear on the system. If it's damaged, you want to have it repaired locally. If you have a plow, anytime you plow on a traffic coating system, you want to have a rubber tip plow. But if you do have any damage like that, something scrapes against it, you want to have it repaired to extend the life. But I'd say anywhere from 7 to 10 years you could get out of a really good traffic coating system.
Thank you. Our next question: if you were looking at building a parking garage, what is the best method to determine a budget cost without having to get a contractor involved?
Okay, without having to get a contractor involved. Well, you could have a professional cost estimating firm help you with that. There are some rough numbers that designers are familiar with for precast and cast in place, but sometimes the best option that I've found when I work with owners is just to get a trusted construction management firm on board. And what they'll do is, if you have a designer run some really preliminary, we call them conceptual plans. You put the conceptual plans together, and then you send it to the construction management firm that you trust. So you have one that you're comfortable working with. They can send it to all the sub consultants just to say, hey, this is conceptual, but can you give me some budget numbers? And they can put together some good, foundation numbers for you, all the mechanical, electrical systems, and just give you an idea as to what those numbers would be.
Okay, thank you for that answer. Our next question is, well, they start out with saying, thank you so much for this presentation. Are there considerations, are considerations any different for below grade structures, or are there unique considerations for that condition?
So below grade structures are typically, let me think here. So a lot of times with below grade structures, you have like slurry walls or something like that on the outside. So sometimes the defects that you find there are different. We have cracked, you have leaking walls and whatnot, so you got to grout them and deal with them a little differently. Below grade, let me think. It's usually a cast in place concrete system. And you've got vehicles entering from the top, so you typically see more defects from where the vehicles are entering and coming down into the garage. We do see a lot of traffic coding systems applied to those below grade structures. But from a structural standpoint, I would probably look at it similarly. Some of the things that come to mind with below grade is that you need mechanical ventilation, so there are a lot more systems to worry about with maintaining in addition to the structural systems. So I think that's about, you know, structural systems are generally the same, and then the mechanisms of deterioration are generally the same. So we just need to look at each situation the way it is and how to address the repairs that need to be done.
Okay, well, thank you for that answer. We have time for one more question.
Okay.
Where do I start to create a maintenance budget for my parking garage?
Okay, great. So you have to kind of understand what your structure, your structure is first, and you start to work around the entire structure. So I was talking about the floors first. You look at the floors. Okay, if you have a precast garage, you quantify all of your joint sealants and figure out how many linear feet of joint sealants do I have, and start to build it that way. You can look at your square footage and come up with a maintenance. Say, okay, I'm going to anticipate with the age of my structure, I'm going to anticipate X number of square foot of top surface repairs and some underside surface repairs that are priced differently. So you start to just build it that way based on where your structure is in its life cycle, how old it is. And I think it just needs to be really tailored to each specific structure and how to go about building that, just kind of like from a practical standpoint as to what's going to need to be done and how often.
Okay, well, thank you for that answer. And it seems we've come to the end of our questions. I don't see any more in our chat box, and we've come to almost the end of our time. So I'm going to say, Allison, thank you so much for a very informative webinar today, and I'm sure people will be getting back to you with questions that they have in the future. And to our attendees, thank you so much for taking time out of your busy schedule to be with us today. So until next time, be safe, stay safe, and be kind to one another. Thank you so much. Bye-bye now.
Thank you, everyone.